4i absolute 0. 4ai minus 196 degrees Celsius. Absolute 0, 0 K equals minus 273 degrees Celsius. 4b increased pressure. Particles of gas move faster or have more K momentum velocity. Any two from. More frequent collisions of particles with walls. Particles collide with walls with a larger force or larger impulse. Greater change in momentum of particles causes greater force on walls. Pressure equals force area. 4C pressure equals 60 kilopascals or 6.0104 pascals. P1V1 equals P2V2 or P2 equals P1V1 V2 or PV equals constant. Or P1V or 1.21050.5 or 6.010 N. 5a 0 degrees Celsius and 100 degrees Celsius. 5 by 1 has uniform, linear expansion or has equal expansion for each degree of temperature rise. 2 has capillary tube of constant cross-sectional area, diameter, radius, bore, width, thickness. 5 BII compared with thermometer B. A has a capillary tube of greater cross-section, diameter, radius, width. Or A contains a liquid with less expansion per degree, unit temp, rise. Or A is longer than B. Or A has a smaller bulb. 5B compared with thermometer D. C has capillary tube that is narrower, of smaller cross-section, thinner. Or has a larger bulb or bulb containing more liquid. Or contains a liquid with greater expansion per degree, unit temp, rise. Or contains alcohol instead of mercury. 5C diagram to show 3 wires labeled e.g. copper, iron, copper or with symbols for metals. Or metal A, metal B, metal A. 1 junction between different metals. Connections to voltmeter, ammeter, galvanometer are identified by V, A, G, MB, Ma or arrow in a circle. 5 CII measurement of a very high or very low temperature or a rapidly varying temperature. Or a high range of temperature. If values given, more than 300 degrees Celsius, less than minus 200 degrees Celsius. 6a convection. 6 by E equals McDeath or 65 times 720 times 7. 3.3 times 105 J. P equals ET in any form or T equals EP or 3.3 times 106 over 1.5 times 103. 220 S. 6 BII2 of. The heater warms walls, floor, ceiling, windows, furniture, objects. Thermal energy conducted through walls, floor, ceiling, windows to exterior. Thermal energy used to raise temperature of air entering room via drafts, openings. 7a1. Solid to liquid. 2. Liquid to gas vapor. 7b. Neighboring molecules of solid have strong forces of attraction between them. Or gas molecules have no weak forces of attraction between them. Easier to increase separation of gas molecules than solid molecules. Gas expands more easily so gas molecules move farther apart. 7 CPV equals constant or P1V1 equals P2V2. Or 0.012 times 1.8 times 106 equals V2 times 1.0 times 105. V2 equals 0.216 meters 3 or 0.22 meters 3. Volume of escaped gas equals 0.22 0.012 equals 0.21 meters 3. 4a thermal energy to change state. To melt solid per kilogram, unit mass not per degree Celsius. 4 by E equals Mc delta T in any form or C equals E per meter delta T. Or C equals 35,000 over 0.35 times 24.5. C equals 4,100 J per kilogram degree C. 4 BII use of 35,000. E equals ml in any form or m equals E L. Or 35,000 thirds 0.3 times 105. M equals 0.11 kilograms. 5a conduction. Conduction. Radiation. 5b electrons move. Lattice molecular particle vibration or W. T. T. E. Or free delocalized electrons. 5c shiny white. Best reflector. 3a renewable, yes. Crops can be regrown to replace resource waste materials don't run out. 3b water will cool too much thermal energy lost during transfer. Lag insulate pipes are transport in a poor conductor of thermal energy. 3c any two from air pollution, harmful gases, acid rain. CO2 greenhouse gases contribution to global warming. Not renewable. Damage from mining, drilling or any valid environmental consequence of transport of coal. 3a any two from amount of water in the pool decreases as water evaporates becomes water vapor gas. The more energetic molecules escape or faster molecules escape or molecules with more kinetic energy escape from the surface of the water. 3b. Lower temperatures, colder day or less windy weather produces smaller pool more slowly because rate of evaporation decreases with decreasing temperature or produces smaller pool more slowly as a draft over surface removes water vapor enabling faster rate of evaporation. 3c. Any 3 from thermal energy in the skin body transferred to molecules of sweat. These molecules have enough K to escape from the skin become water vapor, leaving behind molecules with lower energy, which leaves the skin body at a lower temperature. 4I mass equals 1900 times 0.05 equals 95 kilograms. M equals rho v in any form or 1900 times 0.05. 4AII equals 95 times 1500 equals 140,000 J per degree Celsius 1.4 times 105 J per degree Celsius. C equals M times C. 4AE 34,000 S 560 minutes 9H 20 minutes A3. Temperature rise equals 12 degrees Celsius 19 to 7. Or, E equals C times delta theta in any form. T equals EP in any form or thermal capacity times 12/50ths. 4 sand molecules gain Ke or vibrate more or hit other molecules when heated. Or, thermal energy is transferred by conduction. Energy is transferred to molecules of plastic pod in contact with sand through collisions. Or, energy or lattice vibrations transferred to neighboring molecules. 4BII sand is warmer than surroundings and so thermal energy constantly is lost from the sand. At a constant temperature rate of thermal energy supplied to the sand is equal to rate of thermal energy lost from sand. 4a. Delocalized free mobile electrons. Electrons move through metal or electrons collide with distant particles or electrons carry energy through the metal. Lattice vibrations transfer energy to neighboring particles or particles vibrate and cause nearby, adjacent particles to vibrate or vibrating particles collide with particles transferring energy. 4 Attractive forces between particles are much greater in liquids than in gases. Particles in gases are much further apart than in liquids. 4BII occurs at a fixed temperature. Takes place throughout the liquid. 4C 3.93 J per gram degree C or 3,930 J per kilogram degree C. A4 equals M V or M equals V or 1.03200 or 216. C equals E per meter delta or C equals E per meter delta or 60 and 700 206 75 or 60,700 over 1.0320075. M equals 206 grams or delta equals 75 degrees Celsius. 0625 S 19 Ms 41.pdf. 4i. E equals Mc increment T in any form words, symbols or numbers are. E equals Mc increment T. Or 0.23 times 0.72 times 550. 91 J. 4AII1. T equals. E. P in any form words, symbols or numbers are T equals. E. P or 91/2.4. 38 S. 2. Thermal energy is used to increase the temperature of lost to cylinder piston heater surroundings. 4 It piston moves to the right away from heater or accelerates to right. Pressure of gas greater pressure greater on left resultant force to right. 4 BII V2 equals P1 V1 P2 in any form or V2 equals P1 V1 P2 or 2.9 times 105 times 1.9 times 10 minus 4 over 1.0 times 105 5.5 times 10 to 4 M3 5I any 2 from occurs throughout the liquid or bubbles formed. Occurs at one temperature boiling point. Does not produce cooling or unaffected by draft surface area humidity. 5 AII more energetic molecules escape from the liquid or molecules gain energy and escape or molecules overcome intermolecular forces break bonds. Average speed decreases or molecules with less kinetic energy left behind. Temperature of liquid decreases. Thermal energy conducted gained from skin body or thermal energy lost by skin body. 5b molecules touching or no space between molecules. Large repulsive intermolecular forces when moved closer. 0625 S 19 Ms 42.pdf. 5i boiling. 5 AII evaporation. 5 E equals Mc. Increment T in any form or E equals Mc. Increment T. Or E equals 2.7. times 900 times 18, 44,000 J. E equals PT in any form, or P equals ET. Or P equals 43 and 741 150ths. P equals 290 W. 5 BII lagging insulation, named insulator around, on block. Reduction of thermal energy, heat losses. 0625 S19 Ms 43.pdf. 4a Any 2 from. Bubbles form or occurs throughout liquid. Only occurs at one temperature, boiling point. Does not produce cooling or not affected by surface area, humidity, draft, or does not lower K of molecules left in the liquid. 4b. E equals point in any form. Or, E equals 370 times 240 equals 89,000 J. E equals mc. Increment. T in any form. Temperature increase equals 89,000 5.0 times 420 equals 42 degrees Celsius. 5a Any mention of radiation, infrared radiation, WRT. Silvered surfaces. Silvered surfaces are poor emitters, poor absorbers, good reflectors. Glass is a poor conductor, or glass reduces thermal energy, heat gain by conduction. Vacuum prevents thermal energy, heat gain by conduction or convection. Stopper reduces thermal energy, heat gain by convection. 5b Any suitable insulator, e.g. cork, plastic, rubber. 0625 S20 Ms 41.pdf. 4a Temperature at which liquid turns into gas. 4 by E equals mc delta. T or 0.30 times 4,200 times 100, 95, 6,300 J. 4 BIIC equals E delta T or 6,384, 75 J per degree Celsius. 4b Molecules do work against attractive force as they evaporate. More energetic molecules more likely to escape. Average energy of remaining molecules decreases. 0625 S20 Ms 42.pdf. 3a. E equals mc. Delta T in any form, or E equals mc. Delta T. Efficiency equals energy output, energy input in any form. 15 times 4,200 times delta T equals 5,000 times 3,600 times 0.2 delta T equals 5,000 times 3,600 times 0.2 times 4,200 equals 57 degrees Celsius. 3 BEG Renewable or no air pollution or low running costs or no named polluting gas or no greenhouse effect. Explanation that follows from advantage stated. E.g. expensive to install or not available at night or visual pollution or needs a suitable roof space. Explanation that follows from disadvantage stated. 4a Place in melting ice. When bead has stopped moving or oat mark as lower fixed point, 0 degrees Celsius. Place in steam above boiling water. When bead has stopped moving or oat mark as upper fixed point, 100 degrees Celsius. 4b Bead would not be liquid oat. 4c Thinner bore tube or smaller bulb or use liquid which expands more per unit change in temperature. 4cii Longer tube or larger volume glass bulb or use liquid which expands less per unit change in temperature. 4d Expands uniformly with temperature or same distance between all degree intervals. 0625 S20 Ms 43.pdf. 4a Molecules escape from the surface of the liquid. More energetic, faster moving molecules escape. Slower, less energetic molecules are left behind. Temperature of liquid decreases because average Ke of remaining molecules is lower. 4b Any 2 from. Air temperature increases. More wind. Cloud stops covering the sun. 5 IE equals point in any form. E equals 6,000 J. 5 AII. E equals mc. Delta T in any form. 6,000. 5503320. C equals minus. C equals 0.84 J per gram degree C or 840 J per kilogram degree C. 5 AE Either sum of energy supplied by the heater heats the heater, goes to lagging, goes to surroundings. Specific heat capacity is lower than value in E. Or, some energy may be absorbed from surroundings if they are at a higher temperature. Specific heat capacity is higher than value in E. 5b Specific heat capacity of water is much higher than specific heat capacity of sand. Same rate of energy supplied to sand and C. 5c Cold junction labeled or shown in ice or something similar. Or, diagram with two junctions with voltmeter labeled. Two different metals labeled. Galvanometer or voltmeter joining ends of wires. 0625 S21 Ms 41.pdf. 4a Aluminium is a good conductor of heat and plastic as a poor conductor does not conduct heat. 4 by increase in kinetic energy of molecules or increase in potential energy of molecules. 4 BIINE3 from atoms touching the hot plate lattice vibrate faster. Atoms pass on energy, vibration to neighboring atoms, to other atoms by collision. Atoms pass on energy to electrons. Electrons hit distant atoms or electrons move through lattice. 4b molecules escape from the liquid as a vapor. Bonds broken, attractive forces overcome. Molecules gain potential energy, or work done to separate molecules break bonds, overcome forces. 4 BiV 840 WA3. E equals MLV in any form or 0.11 times 2.3 times 106 or 2.53 times 105. Rate equals MLV T in any form or 0.11 times 2.3 times 106 300ths or 2.53 times 105 300ths. 5a molecules they speed up or gain kinetic energy. Molecules move further apart or push others away. 5b forces between liquid molecules weaker than in solids. Less energy, work done to separate molecules or greater separation for same work done, same increase in energy. 5c greater sensitivity. Volume increase of liquid in second thermometer is greater. Or liquid moves a greater distance for the same temperature increase. 5 CII smaller range in either of. Smaller temperature increase for liquid, meniscus to reach end of tube. Expands more, greater sensitivity in tube of same length. 5D statement of problem e.g. bridges buckle in hot weather. 5DII suggested solution to problem stated in 5D e.g. allow gaps at the ends of the bridge. More detail e.g. as the bridge expands the gaps close. 0625 S21 Ms 42.pdf. 4i random, haphazard, zigzag, irregular. 4aii liquid, water molecules move fast or pollen particles massive. Collide, bombard. Uneven collisions from different directions cause random movement or liquid water molecules move randomly. 4 by cooling. Thermal energy used needed to evaporate ethanol, overcome attractive forces between molecules particles. Thermal energy taken from skin, patient, person. Alternative route for last 2 meters. P. S. More, most energetic liquid molecules particles escape or less least energetic liquid remain. Less least energetic molecules particles linked to lower temp of skin. 4 BII greater, increases faster, higher. 5a air good insulator, poor conductor. Holder, it stops, reduces conduction or. No, less thermal energy conducted to hand. Temperature of outside of holder lower than cup or less energy to skin, hand, person. 5b put a lid cover on cup. Mention of convection. Less no convection from surface. Alternative route for last 2 meters. P. S. Mention of evaporation. Less no evaporation from surface container. 5c radiation. 0625 S21 Ms 43.pdf. 4i energy transferred when 1 kilogram unit mass of a substance freezes or melts. Energy transferred when a substance freezes, melts, changes state. 4aii cup containing mixture of ice and water. Mixture of ice and water will remain at 0 degrees Celsius until all ice is melted, but temperature of water at 0 degrees Celsius rises or reverse argument. Or energy needed for change of state so temperature doesn't rise until this has taken place. 4 by in evaporation more energetic, faster moving molecules with higher kinetic energy escape from surface. Lower energy, slow molecules remain or so remaining liquid is cooler. Thermal energy is taken from person to liquid so person cools down. 4 BII greater, faster evaporation of sweat as wind blows fast moving molecules away or molecules do not re-enter the liquid. 0625 S22 Ms 41.pdf. 3a faster, higher speed, more energetic molecules escape into air. Average speed, average kinetic energy of molecules decreases. Temperature related to speed, energy of molecules are slower, lower speed, less energetic molecules remain in water. 3b any 3 from atoms, ions vibrate. Vibrating atoms, ions hit electrons. Electrons propelled, traveling through metal, moving through metal. Electrons hit distant atoms. Free electrons, delocalized electrons mentioned. 4i2, 3 wires of at least 2 different metals. 1 junction in sulfur. The other junction in ice-water mixture, at room temperature, and one of the wires must be from the first junction. Labeled voltmeter symbol correctly connected. 4AII measure electromotive force. How to find temperature from electromotive force, e.g. use calibration graph or calculation or table. 4B measures high temperatures, wires do not melt, rapid response, robust, small heat capacity, electrical output can be remote from observer, direct input to computer. 5A temperature, at which liquid becomes a gas or liquid and gas exist together. 5 by 1.8. 105 J. E equals VIT in any form or 230. 13. 60 or 230. 13 or 3000. 5 BII 9.110 - 3 kilograms per second 9.110 - 3 kilograms per second A4. T equals 100 to 22 or 78 or T equals 100 to 22 or 78. M equals E, C, T in any form or 1.8 105 4278 or rate equals P, C, T in any form or M equals E, C, T and E equals PT. 1, 8 and 105 4278 60 or 5.510 N or 9.1 9.210 N or 3000 4278 or 230 and 13 4278 or 9, 1/9.210 N. 5C1 if the tap becomes live or if the live cable touches the metal tap. There is a current to earth in the earth wire which blows the fuse. 2. The current in earth wire is large and fuse melts, blows, stops current, breaks circuit. 6A any 3 from radiation, light, infrared, electromagnetic radiation. Travel through space, vacuum. Absorbed by road. 6B road black surfaces are good absorbers of radiation or C is a poor absorber of radiation. 6C they molecules speed up or gain kinetic energy. They molecules move further apart. 6CII density of air above road decreases or density of hot air decreases. Air above land road rises or air that is hot rises. Air above road replaced by cool air, air from above sea. 0625_S22_Ms_42.pdf 1 IE equals 2,200,000 J or 2.2. 106 JA3. E equals point in any form. E equals 600. 3600. 1 AII chemical. 1 BT equals 8600 S or 140 minutes or 2.4. H or 2H 24 minutes. Or, T equals 8800 S or 147 minutes or 2H 27 minutes. T equals 2.2. 106 250ths or 600. 60 250ths or 1. 600 250ths. 1 C any 2 from. Less noise or no noise. Less or no air gaseous pollution from the bicycle or does not produce acid rain. The bicycle uses no less fossil fuel. Does not contribute to greenhouse effect or does not release CO2. 4A statement. Bore of constant cross-sectional area. Explanation. Idea of same movement, change in length of liquid thread. And, for same increase in volume, expansion of liquid. Statement. Liquid has constant thermal expansion. Explanation. Liquid moves same distance for each degree C temperature rise. 4B heat capacity, it is small. Only needs a small amount of thermal energy to raise its temperature. 4C36 JA3. E equals C. T in any form. E equals 0.11. 345 to 20 or T equals 325 degrees Celsius. 0625_S22_Ms_43.pdf 4I zigzag motion, random changes of direction. Random length of path in each direction. 4AII any 4 from. Air molecules bombard smoke particles. Air molecules are small compared to smoke particles, have smaller mass. Air molecules are very fast moving. Air molecules move in random directions. Collisions exert unbalanced forces on smoke particles. B4. 4 by kinetic energy and potential energy of molecules increase, hence internal energy increases. 4 BII bigger change in momentum of molecules or molecules hit the walls harder. Molecules hit more often, more frequently. 5A energy required to raise the temperature of 1 kilogram, 1 gram, unit mass of a substance by 1 degree Celsius, unit temperature. Energy required to raise the temperature of a substance by 1 degree Celsius. 5 by 0.50 kilograms. Equals. MV in any form. 5 BII 190,000J 1.9. 105 J 190 kilojoules A5. E equals mc. Increment T in any form. E equals ml in any form. Use of C equals 4200 J per kilogram degree C. And increment T equals 5. Use of C equals 2100 N. Increment T equals 18. 0625 underscore S23 underscore Ms underscore 41.pdf. 3a heated hotter, warmer air is less dense or cooler air is more dense. Heated hotter, warmer air rises to ceiling displacing cooler air or cooler air falls displaced by warmer air. 3 by speed, velocity of particles increases or they move faster. 3 BII higher temperature means particles collide with rubber harder, with more force with greater momentum change. Larger volume means particles collide with rubber less frequently. Or, larger volume means larger surface area for particle collisions. Effect of larger volume cancels effect of increased temperature, OT. Or, the effect of larger area cancels the effect of larger force, OT. Or, P equals F, A so T. The two changes cancel each other, OT. 4IC equals increment E per meter increment or increment E equals mc increment. Increment equals 21.519 or increment equals 2.5 degrees Celsius. Increment E equals 0.6042002.5 or increment E equals 0.604221.519. 4AII maximum possible efficiency equals 3.1% or 0.031A4. E equals point or E equals point or E equals 13,500 or E equals 6,500. Efficiency equals useful energy output total energy input 100%. Or efficiency equals useful energy output total energy input 100%. Or efficiency equals 6500, 6300, 6500. Or efficiency equals 206,500 100%. Or P equals ET or P equals ET or P equals 6 and 300/500 or P equals 12.6 W. Useful power output equals total power output, wasted power output. Or useful power output equals 13, 6,300/500. Or useful power output equals 13 to 12.6. Efficiency equals useful power output total power input 100%. Or efficiency equals useful power output total power input 100%. Or efficiency equals 0, 4/13,100%. 4b any one from. Temperature change is an underestimate due to thermal energy losses. Thermal energy is transferred from the water to air beaker bench. Energy other than light transferred in lamp filament glass internal structure. Some water evaporates. 10I speed decreases from x to y and then increases from y to x. 10AII any 3 from. Gravitational potential energy GPE transfers to kinetic energy KE or vice versa. K transfers to GPE from x to y and GPE transfers to KE from y to x. Speed decreases as K decreases, aura. Most GPE at y or least GPE at x. Total of GPE plus K energy is constant. 10 by minus 230 degrees Celsius. 10 BII white surface is a poor absorber good reflector poor emitter of IR radiation. Or black other surface is a good absorber poor reflector good emitter of IR radiation. Any one from. The white surface increases in temperature less when facing the sun. The white surface decreases in temperature less when facing away from sun. The black other surfaces increases in temperature more when facing the sun. The black other surface decreases in temperature more when facing away from sun. Less variation in temperature on white surface during one whole rotation. 0625 underscore S23 underscore Ms underscore 42.pdf. 4a pressure decreases and particles have smaller velocity, momentum, smaller EK, kinetic energy when temperature is lower. Lower rate frequency of collision of particles. Particles collide with smaller force or smaller impulse change. 4 by minus 273 degrees Celsius. 4 BII temperature at which particles have least EK, kinetic energy. Lowest possible temperature. 4 C200 CCA3. PV equals constant or 9.010435 equals 1.6105 V2. V2 equals 9.010450, 1.6105 or V2 equals 2.010 N or 1.9710 N. 5I equals M, V or M equals V. M equals 1.24.56.12.4 equals 79 kilograms or M equals 79.056 kilograms. 5 AII 290 SA4. C equals increment E per meter increment or increment E equals Mc increment or increment E equals 79, 1000, 4.0 or increment E equals 316,000 or increment equals 4.0. P equals increment E T or increment E equals point or increment E equals 1100 T. T equals Mc increment P or T equals 79, 1004, 0 1100 or T equals 316,000 1100. 5 AE anyone from. Thermal energy is transferred to furniture, walls, objects in the room. Thermal energy is transferred through windows, doors, floor, ceiling, from the room. 5B conduction and convection. 0625 S23 Ms 43.pdf. 3I greatest gas, least solid. 3AII any 3 from. Solids particles vibrate. Gases particles move freely. Solids particles in fixed, close positions. Gases particles randomly arranged in container, wide separation. Gas particles move quickly. 3 by specific heat capacity is the energy required to raise 1 kilogram unit mass by 1 degree Celsius 1 K 1 Kelvin unit temperature. Energy required per unit mass 1 kilogram. Or energy required per unit temperature 1 degree Celsius increase 1 K increase 1 Kelvin increase. 3 BII time. Mass. Initial temperature and final temperature. 0625 W19 Ms 41.pdf. 0625 W19 Ms 42.pdf. 4 AE equals VIT in any form or E equals VIT. Or E equals 3 times 12 times 23 times 60. E equals 50,000 J. C equals E increment T in any form or C equals E increment T. Or C equals 49 and 680 50ths or 50,000 50ths. C equals 990 J per degree Celsius. 4B1. Larger sphere emits, radiates, loses thermal energy. More. Greater surface area. 2. Greater rate of radiation. 0625 W19 Ms 43.pdf. 4 solids, molecules in lattice arrangement. Solids, strong forces between molecules. Liquids, molecules not fixed in place or molecules have an irregular arrangement or molecules slightly further apart on average than in solids or spaces between the molecules. Liquids, average forces too weak to keep molecules in a definite pattern or forces just enough to hold molecules in the bulk of the liquid. Gases, molecules far apart. Gases, weak, no forces between molecules except during collisions. 5A energy equals power x time in any form. Equals 3000 times 3.5 times 60. Equals 630,000 J. 5BE equals Mc increment T in any form. M equals 1700 1000ths. Increment T equals 100 to 19 or increment T equals 81. E equals 1700 1000 times 4200 times 81. Equals 580,000 J. 5C efficiency equals useful energy output total energy input or 580,000,630,000 times 100. Equals 0.92 or 92%. 0625 W20 Ms 41.pdf. 4A molecules closer. Molecules move only small distances between collisions or do not move freely. Molecules move in clusters or slide past each other. 4B molecules in liquid move faster or gain energy. Molecules move apart on average. 4C molecules overcome forces gain potential energy as the liquid boils. 4CIIM equals rho V in any form or 0.86 times 50 or 43 grams. LV equals Q divided by M in any form or 18,000 43ths or 18,000 over 0.86 times 50. 420 J per gram or 4.2 times 105 J per kilogram. 5A electrons mentioned. Electrons travel a great distance through the metal or vibrating atoms hit free electrons. Electrons hit distant particles or transfer energy to distant atoms. 5B shiny surfaces are poor emitters of radiation. Infrared radiation mentioned. Less energy lost or lost energy does not need to be supplied. 5C less thermal energy emitted or less space for energy to be lost. 0625 underscore W20 underscore Ms underscore 42.pdf. 3 output. P equals V or E equals VIT or E equals point in any form words, symbols or numbers. Or P equals V or P equals 240 times 9 or P equals 2160 W. Or E equals 240 times 9 times 60 equals 129,600 J. Rate of energy input equals 720,000 60ths equals 12,000 J s. Or energy input equals 720,000 J. Efficiency equals 100 times output power input power. Or 100 times output energy input energy. Words, symbols or numbers. Efficiency equals 100 times 2,160 12 thousandths. Efficiency equals 18%. 4a thermocouple. 4b delta. T equals 1. 7/5.4 times 100. T equals 31 plus 20 equals 51 degrees Celsius. 4c any application involving higher, lower temperatures or rapidly changing temperatures or on vibrating machinery or remote sensing or data logging or small areas masses. 5i thermal energy needed to change state of unit mass 1 kilogram of material not per degree Celsius. 5 molecules must be separated or intermolecular bonds must be broken, overcome. Work done against bonds or energy is required needed. Not increase of K, speed. 5b, E equals ml in any form or L equals E, divided by m, words, symbols or numbers. M equals 1.5 or 1500 or 3.82.3. Or 3800. 2300. L equals 1.26. Times 106 divided by 1.5 equals 8.4. Times 105 J per kilogram. 5C insulate or apply lagging insulation to container. Reduction of thermal energy, heat losses. 0625 underscore W20 underscore Ms underscore 43.pdf. 5A cork on black plate, side B falls off before cork on shiny plate, side A. Black surface are better absorbers than shiny surfaces. Or shiny surfaces are better reflectors than black surfaces. Black surface are better absorbers than shiny surfaces. Or shiny surfaces are better reflectors than black surfaces. N. Of infrared radiation. Wax on black plate, plate B melts before wax on shiny plate, plate A. 5B conduction. 0625 underscore W21 underscore Ms underscore 41.pdf. 2A quantity of thermal energy or energy to increase temperature or energy transferred by heating. Energy to increase temperature of an object per degree Celsius 1 degree Celsius. 2 by internal energy depends on kinetic energy of molecules. Kinetic energy of molecules decreases or potential energy of molecules decreases. 2 BII delta. E equals Mc delta. T in any form or 0.24 times 4200 times 17, 1.7 times 104 J. 2 CK. E, of molecules thermal energy absorbed from water, surroundings or energy absorbed from cooling water. Supplies latent heat or energy used to overcome intermolecular forces to break bonds. 2 CII any determination of mass. Determine change in mass of ice, increase in mass of water or dry the ice or ensure water is at 0 degrees Celsius, equilibrium is established or insulate the beaker. Use LF equals E per meter in any form. 3A any 3 of they molecules collide with inner surface. Momentum of a molecule changes reverses. Force exerted, impulse. Force spread over area, surface R. P equals F A 3 by V2 equals P1 V1 P2 in any form or 630 times 1.0 times 105 over 1.4 times 105 450 centimeters 3 or 4.5 times 10 minus 4 centimeters 3 or 0.45 cubic decimeters. 3 BII any 2 of molecules move more slowly, have less kinetic energy. Pressure inside balloon decreases or pressure is directly proportional to temperature or P. Proportional. T. Volume is directly proportional to temperature or V. Proportional. T. Molecular collisions less frequent. Molecular collisions less violent, hard, exert smaller impulse. Water, external pressure compresses balloon or water pressure greater and balloon compressed. 0625 underscore W21 underscore Ms underscore 42.pdf. 4A statement renewable. Explanation wind is replaced, replenished or does not run out or is not used up or is an infinite energy resource. 4B any 2 from Geothermal. Nuclear. Tidal. 4C chemical. Gravitational potential. 5A wires of two different metals. One junction clearly in each liquid. Voltmeter, ammeter, galvanometer correctly connected. 5B any two from. Expansion of liquid. Expansion of solid. Expansion of gas. Density of liquid. Electrical resistance. 5C any two from. Large range. Measure high temperatures. Remote sensing. Small size or small mass. Small thermal capacity. Suitable for data logging. Responds quickly or measures rapidly varying temperatures or temperature changing continuously. 0625_W21_Ms_43.pdf. 4b4. Temperature of air increases so molecules move faster, their K increases. Molecules collide with walls of container and change momentum. Greater change of momentum when temperature is higher, or collisions more frequent, or harder collisions, or force equals. Rate of change of momentum. Higher force and hence higher pressure. 5I 1.2 kilograms. 7600 0.41 2600 m times equals volume constant, so mass directly proportional to density. 5 AII 0.37 J per degree Celsius. Thermal capacity equals mass times specific heat capacity. 5 AE 48 J. E equals mc. Delta T or 1.2 times 0.50 times 100 to 20 in any form. 5b electrons mentioned. Metals have electrons free to move delocalized, which transfer thermal energy. 0625_W22_Ms_4 extended 1.pdf. 4I240N. F equals Pa in any form or 1.01052.410 to 3. 4AII 5.0 J. WD equals Fx or 240.021. 4B minus 3.5 103 J. E equals CDT in any form or 8921 minus 18 or 89.3 or 89.39. 4C. As the volume decreases, the particles collide more often. As the temperature decreases, the particles collide less violently. Two effects cancel to leave the pressure unchanged, or particles collide with walls, piston, cylinder. 4D. Attractive forces between any two particles larger than in gases. Particles closer together than gas particles, or particles already touching. 0625_W22_Ms_4 extended 2.pdf. 4A any three from. Moving particles have momentum, or particles hit walls. Momentum changes when particles hit walls. Force exerted by particles due to rate of change of momentum. Pressure is total force of particles per unit area of wall. 4B pressure increases. There is a greater change of momentum, or particles exert greater force on same area, or particles move faster, or particles have more K. 4C pressure equals 1.5 105 pascals A3. P1V1 equals P2V2 or P2 equals P1V1 V2 or PV equals constant for fixed M, fixed T. P2 equals 9.0 104 and 170 100ths. 5 AE equals 410 million J or 410 megajoules or 4.1108. JA3. E equals MCT or E equals MCT or 1/200-960-360. T equals 360 degrees Celsius. 5B thermal radiation. Electromagnetic, EM, infrared, IR radiation emitted from block. Travels to worker or is absorbed by worker or travels without needing a medium. 5C conduction. Delocalized, free, moving electrons. Any one from. Electrons move from outer surface to interior of rollers. Electrons travel throughout the solid, large distances. Electrons collide with distant particles. Lattice vibrations transfer thermal energy to neighboring particles, or particles vibrate and cause nearby, adjacent particles to vibrate, or vibrating particles collide with particles transferring energy. 0625_W22_Ms_4 extended 3.pdf. 3A5 correct. 3 marks, 3 or 4 correct. 2 marks, 2 correct. 1 mark. Gravitational potential. Water. Tidal bay. Kinetic. Turbines. 3B any one advantage from. Renewable. Reliable or predictable. Running cost low. Does not produce harmful pollution. Any one disadvantage from. High cost of construction. Possible effects on marine life. Not available all day. Power produced doesn't always match with peak demand. Limited number of sites. Maintenance difficult. Increased corrosion because underwater. 3C moon. 4I any one from. Volume of liquid. Length of thread, liquid in tube. 4AII more or greater sensitivity. Volume of liquid, length of thread increases more per degree Celsius, unit temperature because greater volume of liquid present. Or more liquid to expand so gives a larger change in the level of the liquid per degree Celsius, unit temperature. 4a longer capillary tube. Liquid can expand further so to a higher temperature. Or, smaller volume bulb. Less liquid so liquid expands less, lower rise per degree Celsius. Or, larger diameter, wider capillary tube. Lower increase in level for each degree C. Or, replace liquid with a liquid with lower expansivity. Liquid expands less for each degree C. 4b electromotive force. 5a energy from the sun transfers to, is absorbed by water molecules, so K of water molecules increases. Molecules with higher energy Ke, faster moving molecules escape from the surface. Wind removes molecules when they have left the surface so they do not re-enter the liquid. Any one from wind increases the rate of evaporation. Absorption of energy from the sun increases the rate of evaporation. Least, less water evaporates, lower rate of evaporation from dish C. Most, more water evaporates, higher rate of evaporation from dish B. 5b energy to change 1 kg unit mass from liquid to gas to liquid without changing its temperature. Energy to change from liquid to gas to liquid. Or energy to change state of 1 kg. 5ca, temperature of solid ice increases and C, temperature of liquid water increases. B, solid ice changes to liquid water or solid ice melts at constant temperature. D, liquid water changes to gas, steam or liquid water boils at constant temperature. 0625_W23_Ms_41.pdf. 2a any 3 from free delocalized mobile electrons. Electrons gain thermal energy from hot plate particles. Electrons move throughout copper, metal or electrons move to distant particles. Electrons transfer energy from higher temperature region to lower temperature region or electrons collide with. Distant particles transfer energy to distant particles. 2b shiny surfaces are poor emitters of radiation. Reduces energy loss from the pan, copper or less energy transferred to surroundings. 2c convection. 5a any 3 from description of how the energy from water is released. Mention of transfers between energy stores. Moving water turns turbine. Turbine turns drives generator. Name of method to match description. 5b advantage of generating electricity from energy stored in water. Disadvantage of generating electricity from energy stored in water. 5c any 2 from geothermal energy power. Tidal energy power. Nuclear energy power. 2i evaporation. 2ai air is drier. Because water vapor has condensed, turned back to liquid in the condenser. 2b gravitational force or weight. 2b force is perpendicular to the motion of the clothes. 2c uses solar, wind energy which is renewable or energy resources not used to generate electricity or greenhouse gases not produced or does not use fossil fuels. 0625_W23_Ms_43.pdf. 4i absolute 0. 4ai minus 196 degrees Celsius. Absolute 0, 0 K equals minus 273 degrees Celsius. 4b increased pressure. Particles of gas move faster or have more K, momentum, velocity. Any 2 from more frequent collisions of particles with walls. Particles collide with walls with a larger force or larger impulse. Greater change in momentum of particles causes greater force on walls. Pressure equals force area. 4c pressure equals 60 kilopascals or 6.0104 pascals. P1V1 equals P2V2 or P2 equals P1V1, V2 or PV equals constant. Or P1V or 1.21050.5 or 6.010 N.